We're going to talk about bonding, the idea that elements bond together to form compounds. So the definition for a bond is that it's the force holding atoms together in a compound. So the chemical formula for water is H2O. What that means is that you're going to have an oxygen chemically bonded to two hydrogens. So there's actually some sort of chemical connection keeping the oxygen and the hydrogens together. And that chemical connection is called a bond. There are three main types of bonds: ionic, covalent, and metallic. We're going to talk about each of the three briefly, and then later on we'll go into more detail on ionic and covalent. So ionic bonds form by the actual giving and taking of electrons. One element is losing its electrons, another element is taking the electrons, gaining the electrons. So typically ionic bonds are going to form between a metal and a nonmetal, since metals want to lose electrons to get to the octet and nonmetals want to gain electrons. So if you look at sodium, sodium is 1s2, 2s2, 2p6, 3s1. So it's got that one valence electron, 3s1, so that's its electron dot diagram. If we then look at chlorine, 1s2, 2s2, 2p6, 3s2, 3p5. Its valence electrons are also in the third energy level, s2, p1, p2, p3, p4, p5. So there's our electron dot diagram for sodium and our electron dot diagram for chlorine. Okay, I'm going to clear this out real quick just so I can show you this more clearly, but this is how we got those electron dot diagrams. So here's sodium with its valence electron. Here's chlorine. Remember, it had three pairs and a single. So what's going to happen is sodium is going to give its electron to chlorine. That means everything will be happy now. Everything will have an octet. So sodium is losing that electron. Chlorine is gaining that electron. Now, remember that electrons have that negative charge. So if we're gaining and losing electrons, we're also gaining and losing charge. So when sodium gives its electron to chlorine, that means I now have sodium left with a positive charge. Chlorine takes that electron. I now have chlorine with a negative charge, and I have the ionic compound sodium chloride, otherwise known as salt. And it's this positive negative attraction that will keep this together as the compound overall. So sodium gives its electron to chlorine, leaving sodium with a positive charge, chlorine with a negative charge. The positive and negative will attract to each other, so NaCl will stay together as a whole compound, salt. And again, it will typically be a metal, sodium's in the metal side of the periodic table, with a nonmetal, chlorine's over on the nonmetal side, because metals want to lose their electrons, nonmetals want to gain electrons. Covalent bonds are a little bit different. They're going to form by sharing electrons, and so typically in order to do this you're going to have two nonmetals. So let's look at chlorine, and we showed that chlorine has this electron dot diagram. Okay, three pairs and a single. Let's put another chlorine over here with three pairs and a single. Now, if this chlorine gives its electron to the other chlorine, that would make this chlorine happy, but that would leave this chlorine with only 6 electrons. So that doesn't do it any good. Remember, everything wants 8, so giving and taking of electrons does not work in this case. What does work is if they share that electron pair. That gives this chlorine 2, 4, 6, 8. And that gives this chlorine 2, 4, 6, 8. So by sharing that electron pair, we now have a covalent bond. And you'll sometimes see that written like this. Oops. Where you have to understand that this line represents that shared electron pair. So we now have two chlorines hooked up together, so this would be the formula for that compound. So again, covalent bonds are different. We're sharing. It's not like one's actually giving it away, one's actually taking it. They're sharing electrons, and that's going to be a covalent bond. And then finally is metallic bonds. Metallic bonding occurs within a single metal. Metals do not bond with other metals. So what happens is, let's say you have a sheet of aluminum foil. Okay? In that sheet of aluminum foil, you have all these aluminum atoms all bunched up together. So all of these are aluminum atoms in my aluminum foil. This aluminum atom has some electrons zinging around in the orbitals. What happens in metallic bonding is the orbitals overlap, so the electrons are able to move throughout the metal. Okay, so the electron that starts off in this atom might end up over here, and then over here, and then down and down and over. They just flow freely throughout the metal atoms. So metallic bonding is described as a sea of moving electrons, because what's happening is just all of these electrons are flowing freely throughout the metal. So it's just this sea of moving electrons. This is actually why metals are such good conductors of electricity. Electricity is the flow of electrons, and so since the metal already has electrons flowing through it, the additional electrons from the electric current flow really well too. Again, the important piece of this is that this occurs within a single metal. So just within a piece of aluminum, just within a copper wire, just within a magnesium ribbon. Metals do not bond with other metals. You will never have aluminum hooking up with copper, or you will never have zinc chemically combining with iron. That does not happen. Metals do not bond with other metals. This only occurs within a single metal. So those are the three main types of bonds: ionic, covalent, and metallic. We'll talk more about ionic and covalent bonds in a little bit more detail later on, but that's the basics.